Welcome to Saxon Math, Course 3, Lesson 104, Volume, Capacity, and Mass in the Metric System. Now, we're going to be talking today about unit conversions for water. We're going to be going between volume, capacity, and mass. Volume is the space inside of a shape. Capacity is the amount of liquid a shape could hold. And mass is the weight of that liquid. So we're talking about a shape's volume, its capacity, and its mass when it's filled with water for today's lesson. Now, if we have a shape filled with water, it'll be 1 cubic centimeter will equal 1 milliliter. 1 milliliter will equal 1 gram. When we have a line written like this, we can pick any two of them, and those two are equal. So 1 cubic centimeter is 1 milliliter, and 1 cubic centimeter is 1 gram. 1 milliliter is 1 cubic centimeter, and 1 milliliter is 1 gram. Similarly, 1,000 cubic centimeters is 1 liter. 1 liter is 1 kilogram. 1 cubic meter is 10 to the power of 6 milliliters, or 10 to the power of 3 kilograms. Now, you should have all of these down in your notebook. You're going to need to refer to them later. You should have these memorized at some point. Starting example 1. Ray has an aquarium that is 50 centimeters long and 20 centimeters wide. The aquarium is filled to a depth of water of 40 centimeters. Part A says how many liters of water are in the aquarium. First, we need to find the volume. The volume is length times width times height, so 50 times 20 times 40. 50 times 20 is 100. 1,000 times 40 would be 400,000. Centimeters cubed. So if we have 400,000 centimeters cubed, we can multiply by 1 liter over 1,000 centimeters and get 400 times 1 liter is 400 liters. Well, what is the mass of the water? We'd find the mass of the water by saying that 1 liter equals 1 kilogram. So if we have 400 liters times a kilogram over a liter, we can cancel out the liters, leaving us with 400 kilograms. That's example 1. Moving on to example 2. Example 2 says Malia wants to find the volume of a vase. She fills a 1 liter beaker with water and then uses all but 280 milliliters to fill the vase. First, if we're finding the volume of the vase, we first need to find our capacity. She used a 1 liter bottle but had 280 left. That means that we can subtract 280 from 1,000 because 1,000 milliliters is 1 liter, and we'll get 720. For x, this is 720 milliliters. Since 1 cubic centimeter equals 1 milliliter, we can say that 720 milliliters times 1 cubic centimeter over 1 milliliter, cancel out the milliliters, and we'll have 720 cubic centimeters. Part B says, if the mass of the vase is 640 grams, what is the mass of the vase when it's filled with water? Well, 1 cubic centimeter is 1 gram. So the vase plus the water will be our total. So we know that it has a capacity or volume of 720 cubic centimeters, we know that the water in the vase will be 720 grams. If the vase itself is 640, it's 640 grams plus 720 grams. 720 plus 640 will be 1,360, or 1,360. Example 3 says, on a fishing boat, live bait is kept in a cubic tank measuring 1 meter on each edge. A says find the volume of the tank. The volume is found by length times width times height. If volume equals length times width times height, if it's a cubic meter, it's going to be 1 meter times 1 meter times 1 meter. 1 times 1 times 1 is 1 meter to the power of 3. We then have to find the capacity. Well, 1 cubic meter is 1 million cubic centimeters. So we're going to do 1 million cubic centimeters times 1 milliliter per centimeter cubed times 1 liter per every 1,000 milliliters. And the reason we do this is in liters, our answer is going to be a little bit simpler. Now, we can cancel out, divide by 1,000, giving us 1,000 liters. Now, if we're approximating the weight, we know that every liter is a kilogram, so it's going to be 1,000 kilograms. If we know that 1 kilogram is 2.21 pounds, we can do 1,000 times 2.21, which will give us 2,210 pounds. I'm sorry, I didn't move the camera there. Here we found that based on the 1,000 liters, it has a weight of 1,000 kilograms. A kilogram is 2.21 pounds, so we multiplied out here. Example 4 says to increase water supply, they replace the existing tank with one whose dimensions are 30% larger. If the old tank's dimensions are 10 meters tall and 20 meters in diameter, what are the new dimensions? Is it A? Or how much does the new tank hold? What's the capacity of the new tank? So, is it A, 3.4 times 10 to the power 5, B, 4.1 times 10 to the power of 8, or C, 6.9 times 10 to the power of 6? Well, our old dimensions will give us our old volume, and our new dimensions will give us our new volume. Now, our old volume would have been 10 times 10 squared times pi. Well, 10 squared is 100 times 10 is 1,000, so this would be 31.14 times 1,000, which would be 3,140. Now, in order to find the new volume, we can use the scale factor in dimensions, which is 1.3, and we can use that to find the scale factor for volume. Now, when we found the scale factor for area, it was our scale factor squared. When we find the scale factor for volume, it's going to be our scale factor cubed, or to the power of 3. So 1.3 times 1.3 times 1.3 is 2.197. So if we take the old volume of 3,140 and we multiply by 2.197, what we'll get, well, let's do the math. 7 times 0 is 0. 7 minus 4 is 28. 7 times 1 plus 2 is 9. 7 times 3 is 21. 9 times 0 is 0. 9 times 4 is 36. 9 times 1 plus 3 is 12. 9 times 3 is 27, plus 1 is 28. 2 zeros are dropped for the 1. 1 times 0 is 0. 4, 1, 3. We'd put 3 zeros as we move to the 2. 2 times 0 is 0. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. 0 plus 0 plus 0 plus 0 is 0. We'd have 8. 9 and 6 make 15. 1 and 2 and 4 make 8. 2 and 8 and 1 and 8 make 19. 1 and 2 and 3 and 2 make 8. And 6 is 6. We have 1, 2, 3 decimal places. 1, 2, 3. So we'd have 6,898.58